PiLAF skill development in R training, and it's been a while here. Okay, so we started with ggplot last week. Prof kicked us off with ggplots, and we've had a solid foundation. So today we'll be taking it further, and this will be the last dedicated class for ggplots for visualization. So as time goes on, we'll be looking at, as we enter the inferential part of the training, we'll be seeing more dedicated, customized, and specific visuals as pertaining each method we are looking at. But what we started since last week is to start with basic visuals and just get our way around how ggplot works. So like we were told last week, ggplot means grammar of graphics. The GG in plot means grammar of graphics, and it's the easiest and official way of plotting in R. All right, so to start to dive in, because we have a long way to go today. So the objective for today is that at the end of this session, you should be able to use the three parts of ggplot effectively, develop univariate plots, and develop bivariate plots. And to break that down, we'll be looking at how to build ggplots piece by piece. Then one variable continuous, one variable discrete, two variables, those are the bivariate plots now. Two variables continuous and continuous charts, two variables discrete and continuous charts. When we have discrete x and continuous y, then two variables discrete x and discrete y. All right, so this is from last week's slide that Prof used. Just a reminder, a revision in case you have not gone through it since last week. So the components of ggplots, there are basically three broad components of ggplots. Each of them have, okay, so according to ggplots, two concepts. A plot can be divided into three different fundamental parts. No matter how complex or simple that plot is, it can be divided into three. The plot is divided into the data, the aesthetics, and the geometry. The data is the data frame, like Excel or CSV. We use CSV, the demographics data last week, and that's the same data we'll still be using this week. All right. So it was a CSV data, but if you download it as an Excel data, you can also import it into R. Then the aesthetics is used to indicate the X and Y variables. It can also be used to control the color, the size, or the shape of points, the height of bars, and so on, whatever you are using in that graph or in that plot. Then the third part is the geometry. The geometry corresponds to the type of plot. So when you pass in your data, you pass in the aesthetics. ggplot is still, R is still waiting for you that what am I to plot? Am I to plot a scatter? Am I to plot a line graph? We've seen some of them. Am I to plot a box plots? So the geometry is what type of plots that would come out. So these three parts of any plots, being able to use them effectively would help us to create good charts, like customized charts and all. Now, I need to say that every part of the R charts, every part of the charts can be maneuvered. You can customize it anyhow you like. Think of something. It's just more of reading the documentation that comes with ggplots. If you're able to lay your hands on the documentation, which is in R, you would get more idea out of it. So the purpose of this lecture this training is to make you familiar with these three parts, to make you more familiar with these three parts in creating some more basic plots than what we have done last week. All right. So now, to dive more into it, ggplot2, we can build plots piece by piece. We build plots layer by layer in ggplots, and we learned that also last week. By using the plus sign, we can add different layers to the plot. So we'll see how to create the plot area. I can hear myself. Is someone using two devices? Okay. Graph area, the data, the aesthetics. Okay, yeah. So we'll see, these are the layer by layer. We'll soon see how it is we should demonstrate. The graph area, as a graph object, the area we want to plot charts, and the command that we use for that is ggplots. We have empty, we pass nothing into the ggplots command. or function. Then the data, which is the data we'll be using to in plotting. Then the aesthetic mapping, like we said, passes the variables we are using to plot the maps, the charts. Then geometry indicates the type of plots. Then we have the axis labeling. How do we label the axis? How do we use different themes? So themes, just like we might be familiar with using other apps, themes helps us to do some kind of customization, add some beauty to the charts. Then we also learn how to save ggplots by using the ggsave command. So aside the flexibility of ggplot2 is expressed by using the plus sign to add other attributes to the plots layer by layer. All right. So we'll see how we'll demonstrate this in a moment. Then so I put some materials here where we can go to get more themes. There are a few themes that comes with ggplots. I think they're about the last time I counted, there are like 8, but I'm sure by now there are more than 8. All right, some of them are theme, BW, black and white, light, classic, and all of that. So you can check more. Sorry, okay. So you can check more on GG themes from here. Then you can also install the GG themes library. There's a library. It's like an addition to ggplots. It's it's called GG themes. This GG themes is a library, but we will not be using it today because our focus is on how to use ggplots. Then you can also read more about it here. Then saving as well. We can save in different formats, and these are the formats we can save in. There's JPEG, there's PNG, there's PDF, and every other format that will be almost like any format that you might want. All right, so let's move straight to R Studio. I hope we've all downloaded the R scripts for today. All right. So here is my script. And so the first thing, this is the first, while doing any projects or any work with R, is to set your working directory. We've started setting working directory since class 1. And on my system, my working directory is on my desktop. And it's saved, it's a folder called PiLAF R. Let me go to this is my desktop, and this is the folder, PiLAF R. So whatever I save, whatever my data is inside the folder, and whatever I save from this project is going to be saved directly into that folder. All right. So once my cursor is on the line, I can run it, tell it, let my working directory, set my working directory to desktop and PiLAF R. All right. Now, if you've not installed ggplots after last week's class, you can run this line. But if you have installed it before, you don't have to run this line anymore. So you can put an hashtag here to make it a comment, so that in case you want to run everything from the scratch, you don't have to install ggplot again. Now, I'm bringing tidyverse. I think we use tidyverse also during the data wrangling class. Now, tidyverse is a combination of a group of libraries, and which ggplot is also part of it. So, and ggplot, and when we load the tidyverse library, it also loads dplyr, which is used for data wrangling. So most times, visualization and wrangling goes hand in hand. You might need to wrangle a bit, mutate, filter, select, all of those things we learned during the wrangling class. We might need to use them during doing visualization tasks. So that is why, for me, I prefer to just load the tidyverse library, the tidyverse package, because it's going to load ggplot and dplyr. Yeah, that's dplyr, dplyr. All right. Sorry for the pop-up. All right. Now I'm going to load this by running it from here. All right. So it's still running, and you're going to see how many libraries it's going to load by default. So now if you load ggplots first, you don't have to load tidyverse, because sometimes there can be conflicts in loading two packages at the same time or in different ways. Loading tidyverse and loading ggplots can bring conflicts. So you have to be aware of the libraries you load sometimes. All right. So I don't know why my tidyverse is taking so long time. Okay. So if you don't have TDVers, you can just load ggplots and perhaps load the dplayer library by using library dplayer. Yeah. So if you don't have TDVers, you can load this. All right. So my TDVers has finished loading, and you can see how many packages, or how many packages it has loaded for me. That's like 8. Now there is a conflict here. It's telling me that dplayer filter has masked stats. Stats is R-based function, like normal R. So it's telling me that instead of like stats will not work, filter will not work for the filter for R-base will not work, but filter from dplayer will work. Lag from R-base will not work, but lag, they are basically the same spelling, so you don't have to worry about them. All right, so let's go into plotting. Now load the data as read.csv demographics.csv. That's because the data is in. Yeah. Is someone asking a question? Okay, so so to load the data, we use read.csv, and we are loading the same data we used last week as demographics.csv. Now, sometimes if you are downloading it again, you need to look at the name of the data sets. Sometimes it downloads. It downloads as demographics/demographics. So you have to remove the first demographics and make it look this way. Then put it in your working directory. That is when this code will work. All right. So we run this, and the demo data comes in. So we have 510 observations and 8 variables. Now we can view by running this, or we click it here. All right. So view is a great way to see your data. The way it is in a spreadsheet. Like, you don't have to open an Excel sheet to see what your data looks like. So we have the age, marital status, the income, the education, the car price, the car category, gender, and retired. All right, so looking at this data, we have some numeric variables, and we have some scale, and what some character. All right, so let's go back to here and run the structure, str for structure. You can also run with by pressing Control Enter on your keyboard. Like, you don't have to bring it up every time. All right, so the structure is going to show the makeup of, I don't want to say structure again. It's going to show the makeup of your data variable by variable. So the first one is age, which is an integer. Marital is character. That means it's text, married and unmarried, and so on. So one of the things we need to do while using ggplots or while doing visualization to have effective way or true is to convert your character to factor. Yeah, there are more complex ways of converting, but this is a very simple way to convert. All right. Now remember the demo. We brought in the data as demo. So this is demo. The data is no more demographics. In R, it is demo. So demo and the dollar sign which is used to assess, it's called the assessor, used to assess each variable. So now this is saying that the marital, of course, you can see from here, from the console here, marital variable is character. Okay. Can we mute? If you're not saying anything, you can mute. All right, so the marital is a character. So that's why we are converting it to factor here. So the function as factor converts character to factor. Now you're going to see what it would look like after. Then demo, education, car, category, gender, and retired would also do the same as well. So I don't have to waste time here. I'm just going to highlight everything and run it. Okay, it's done. Now I can check the structure again. I can check structure again, run this line of code again. So now let's see what we have. We have integer. The first one, age, still remains integer. Then marital becomes factor. Income is integer factor. So what's the difference? It's saying marital with 2 levels. We have married, unmarried. So it says married as 1, unmarried as 2. We did not have all of this here before while it was character. So this is what converting to factor does. It helps R to plan your graphs very well. Now, after doing that, we are now going into the lesson mainly. That's to build plots piece by piece, building plots piece by piece. Now, remember we said that ggplot graphs are constructed layer by layer, and most times we add layers using the plus sign. Now, let's start with totally empty plot layer with no arguments. So, the ggplot function will invoke a plot layer that has nothing. So, if we run this just ordinary ggplots, we'll have a layer. All right. So while okay, so let me go to my plots here so we can see, reduce this a bit. Okay. All right. So you see, this is the plot layer. There's nothing, no x-axis, no y-axis, nothing inside the plot. All right. So the first argument to ggplot is the data. As the data we want to plot. In our case, we have the data demo. Now we pass it. There are two ways to pass this: using the pipe operator or using this method. So you can use anyone. They are both the same thing. All right. So ggplot, anyone you feel comfortable with. We've learned how to use the pipe operator during the wrangling class. All right. So now to pass the data into ggplot, we just specify data equals demo and run this. Demo, don't forget, demo is the name of the data we brought in, demographics, and this is data demo here. All right. So after running this, we still have nothing. But internally, ggplot knows that, okay, I have a plot area and there is this is the data I'm plotting from. Okay, if we run this as well, it's going to give the same thing. Now, the second argument we need to pass into the ggplot is the mapping. That's the aesthetics. So we said the mapping specifies the x and y axis. Now, because this is just, I'm just trying to show you how we can build ggplots piece by piece. We are using a very simple bar chart. A very simple, that needs a count, that will just use counts, and we need just x, the x-axis for it. All right, so I'm just specifying an x-axis. So mapping, so AES x equals, I'm passing this like into mapping. So AES x equals retired. Retired is a variable in our demo data. Now, this is just putting it inside an object. Now, instead of putting all of this mapping, I can use AES, the aesthetics function, copy this and use this, replace it here. I can do that. We'll still do that, but don't forget, this is just trying to show how to build plots layer by layer. All right, so we have an object called mapping here, and the mapping does not really mean anything now until we bring it into the ggplot data, into the ggplot function. So now we have ggplot data equals demo and mapping equals mapping. Now, if we run this, remember our mapping is retired, and in the retired variable, just like we have here in the console, you are either retired or not. You're either retired or not. All right. Have I run this? ggplot mapping equals mapping. Okay. Now, yeah, so we should have the yes or no here in the map area. All right. Now, we need to tell ggplot to create a geometry, to tell it what type of plots to create. Now we can do that by, so all the things I've done so far, this is another way of doing it. ggplot demo. So we don't have to put data equals demo every time and put x equals retired. Once we put ggplot, it's by default, the first thing it accepts is the data, followed by the x-axis. Of course, AES. So followed by the x-axis, then the y-axis, then the geom bar tells you to plot a bar chart. Now, all of this, I'm assigning them to an object A. Now, why am I doing this? This is it's important to put your fundamental functions, your basic functions, the core functions that make your map, put them into an object, so that by the time you want to add every other thing like themes, labels, and all of that, you just be using plus, while nothing will tamper with what you have made already. All right, so I'm going to run this, and it's going to assign it to A. So we have A, and if I run A now, we'll have a bar chart. Okay. waiting for my chat to come up. Okay, it's up. All right. Okay, so this is the bar charts. It's really simple. Retired, those who are not retired are more than those who are retired, like we've seen last week too. It's a data we've used very well, so might not really be talking about what is in the data, but we'll try to do that. So we have a simple bar chart. Now, like I said, it's a good practice to save the generic codes in an object. Like the codes we'll be using over and over again. It's good to save them in an object so that any other plot attributes you want to add, like labels and themes, can be added one after the other. So now we want to add labels to this simple chart. Now, so we can do that in ggplot by using the labs function. Now we have the x lab and we have the y lab. As for x, the label we want to put for x is occupational status. So you always write, because it's text, is a label, it's not a variable, it's not a function. So you have to put it in quotation marks. That's why we have occupational status here. Then y, instead of counts, I'm making it frequency. Then title, the title is the big heading, employment status, while the subtitle is what comes after the big heading, count distribution of employment. I don't know what that means. I just put it there. All right, then now all of this, the lab is using, all of the X, Y, title, subtitle are a function of, or they are arguments in the labs function. So that's why there is no plus anywhere here. That's why we have comma, comma, comma. Once we are done with this function, then we can have the plus to tell it, now this is another layer. Another layer is the theme light. All right, so now to run this, I'll put my cursor anywhere in this and run. So we'll have a different chart, the same charts, but different outlook. Yeah, so we have the employment status, counts distribution of employment, then we have the frequency, and we have occupational status. All right, so as I try different themes, e.g. minimum. Now, to try, like, how do I know the theme I want to use? I do not know. I just, like, most times I try different themes. When you have theme and you have I want to see the different themes that we have. If you press the tab, okay, yeah, it's up. So you can see BW, classic, dark, get, gray, the gray of GRAY, GRAY is GREY, and so on. So there are different themes that you can use. So while doing your plot, you can try your hands on different themes until you get something that suits you. In a more complex situation, you can create your themes yourself. Then using that library, GG themes, gives you much more a wider scope of themes to use. All right. So before I give space for questions, let's see another way of adding labels to our charts. Now we have the plots. Okay. So this time around, I'm putting all of the functions into an object called bpplots. That's bar plots, bplots rather. So ggplots demo, that's the data. Don't forget it. Collect three basic things. Then the AES retired, which is only x-axis because we are plotting a very simple bar chart. Then the geom bar, telling it that we want to plot a bar chart. So width 0.7. Now, Prof told us something last week that for every function have their. Hello?
We can hear you.
I can't hear the person. Okay, I thought the person was asking a question. All right. So I was saying that for every function, AES, geom bar, and all of these layers, they have different arguments that can be passed into them. Like there are so much that we could use like 2 hours on each one of them. There's different options that we can have in each one of them. So some of them are width equals 0.7, fill, still blue. So this field is like color. The still blue is color. So it's going to change it to still blue color. Then the title, know your customer, blah blah blah. Now, so where I was going to is this. Now, instead of using the lab function, like we used the other time, here, like we used here, saying labs x equals occupational status. You can just say x lab, the occupational status, y lab, frequency. So this is another way of specifying your X and Y axis if you don't want to use labs. So whichever one that is convenient for you is fine. Now, this is another thing, and here I want to flip the chart, not so that it won't just be straight this way. Sometimes you do that when you're probably presenting and you are presenting a lot of bar charts. You might want to flip some and flip some in another way and so on. So if I run this, we'll have the same charts but different outlook. Okay, so because I've saved it in ggplot, I need to run ggplot as well, so that to give me my chart. Okay, all right. Now we have the same charts, but it is horizontal. Now we have occupational status, we have the frequency, and we have the title. Let me zoom it. We have the title and we have the subtitle as well. So again, majority of the people in these data sets are not retired, while only a few, probably around 10 are retired. All right. So this is a different theme. You can try your hands on other themes as well. All right. So after plotting your chart, you might want to save it. There are two ways of saving. You can use all of these codes, or I think three. While you zoomed, you can right click on the image, then save image as, or you can copy your image and now paste it on Microsoft Word or wherever, or PowerPoint, wherever you need it. All right, that's one method. The second method is to use exports from here. Here you can save as image or save as PDF. So when you save as image here, it gives you some options you can maneuver. The width is 436 and the height is 317, I think, inches or millimeters. It should be millimeters. Then, so this type of the formats can be in JPEG, PNG, and all of this. JPEG is fine. All right. So if I save this now, then okay, of course you can change it. You can change the name. You can change the name here to whatever you want the name to be. All right. So I'm going to change this and call it plot 1. And it's a JPEG. So save. So automatically saves in my working directory. Now, if you want to save with codes, you can do ggSave. Now, because our plot has a name, ggSave, this name, the first name you are giving it is a name you want to give it. It's not the name of the plot. All right. So demo bar plots, JPG, which is JPEG. Now, which plots do you want to save? Plot equals B plots. So I like this because sometimes you've plotted a lot of things initially, and you might want to save maybe the third plots you created. So if you've given it a name, you just specify which plots you want. If you don't give it a name, ggplot will just save the last plot that you made. That's what will be saved automatically. Now the width here equals 5, the height here equals 7. So this plot is going to be quite small. So if you run this as well, okay, let me change this to retired bar plots. All right, so I'm going to run it because I already run the demo bar plots before. So I've saved two. The first one is first plot. The second one is retired bar plots. So if I come to my working directory here, I'll have, this is retired bar plots. And the first one, where are you? Okay, plot 1. All right, yeah, it's here. So plot 1 and retired bar plots is what I've saved. So the charts are both here. All right, so that's what we have on, that's what we put an end to building plots layer by layer. A quick recap is that there are three major layers, or there are three major layers three major parts of a ggplot: the data, the aesthetics, and the geometry. For me, I prefer it in that order. Then for each one of them, there are different functions you can use to bring in whatever to customize your plots. All right, then you add layers using the plus sign. In some cases, the comma. If you are putting a lot of arguments inside the same function, then you separate it by comma. All right. So here, I would like to give an interlude for question, if we have any.
So,
all right.
Can you hear me?
I can
Yes,
hear you.
please. How about the DPI, dot per inch? One needs to maybe increase it to 300 DPI. How is that going to be possible, please?
Okay, that the dot per inch. Okay. Okay.
Yes,
Let
please.
me
Yes, dot per inch. Yes, yes.
okay, dots per inch. That's like what do you mean by dots per inch?
Okay. Like some images,
Okay,
may be
that's the
required
quality
in
of
high
it.
quality.
Yeah,
Yes.
quality of okay. Well, you might try GG documentation, like how to make the. I've not been in a situation where I have to use high quality, but I think if you increase the size, um, I'm assuming now that if you increase the size, it's going to also like increase the quality. Because no matter the size that I've used so far, no matter the size, whether small or large, and sometimes even when I need to enlarge it, it still gives me a good quality. Again, it depends on where I'm using it. I understand what you're saying, but you can check documentation on quality. Mostly, what we see here is, or what we make use of, is size, and no matter the amount of size, you still have a good quality image here with ggplots. Okay. Yeah. Yeah. I can barely hear you.
Hello?
Yeah.
Hello?
Okay.
Can
Hello,
I ask
Mr.
my
Yaride.
question?
Yeah.
Yeah,
Someone was
please,
saying
I
something, but
want
I can't
to.
hear him. So you can continue.
Okay, please, I want a clarification. Please, I want
Okay.
you to please expatiate on when to use plus sign, when to use
Okay.
comma. You said within
Okay.
within an argument you use comma. Then if you want to join two arguments, you use plus.
Okay.
So please, can you a
Functions.
little
Yeah.
bit again functions? Can you a little bit expatiate on that a little bit, please?
Okay. Okay. All right. So let me go back to now. Let me come here. Okay. So we said in ggplots, you build ggplot graphs, function, layers by layer. All right. So, and we said ggplot has three basic parts. The first part is the data. We've seen how to bring in data. The other one is the aesthetics. Now, we said the aesthetics can take x equals. So now, the aesthetics is a function. The x in it is an argument. X. So now, if I want to specify y, then I'm going to put comma. Y equals something else, maybe marital. You understand that? So I'm still in the same function AES. I'm still in the same function AES. I'm passing some arguments into the AES function. So I can use comma in that regard. Now I'm out of AES now. I am using, and then I want to go and specify my geom bar. So the geom bar is another segment of the data of the plots entirely. So I'm going to use plus. I'm going to use plus for the geom bar. Now, after filling that, then I want to add my title. Now, it does not, even if I want to add any other thing, AES, I can still come down anywhere at any point here to use the plus. So whatever you want to add to your ggplots, you can always add it with plus. But if you're adding it in between the function, a function, you use comma to separate it. Is that clear? Mr. Yoridi?
It's clear now. Yeah, it is clear. Thank
Okay.
you so much. It's clear.
All right. All right.
Hello, sir.
Thank you. Yes.
Yes, in your first class, I
Yeah.
think what we used was semicolon. Can we use semicolon in place of the
No,
plus?
it's different. It's different. It's different. So the semicolon, we use semicolon when, like, those ones, they are not connected at all. Remember, for the ggplots, we are trying to build one thing. That's building a chart. The semicolon is specifying different things entirely. What we said then was to give me a word. Okay, JK, we are assigning 32 to JK, or maybe 32 plus 12, then semicolon. And something else, TH, we are assigning um, a text, a string to TH. There is light. this is not like they are independent. They are not related at all. Do you understand?
Okay.
This is not
Yes, sir.
related. But for ggplot, we are trying to build one thing. All the commands or the codes we are writing is to build something, which is the graph. So we either separate the layers mostly through plus and plus and plus. All right.
Thank you.
So
So,
okay.
sorry, this AES function, I'm yet to fully understand it. Like in your mapping, there was this object you created, mapping. I think you used the AES function and you called a variable inside one of the objects.
Okay.
So
Now,
I was thinking you would have used the $sign to call that variable, because calling it alone, I don't know how you'd be able to recognize the variable
okay.
inside the object.
So
without the
what
dollar.
happened? What happened there was that, let me go back there. Okay, yeah, mapping. So I did this because I was only using this to explain mapping, like the AES, the aesthetics mapping. Now I said X equals retired. Now this is a totally independent code. So what I now did was this mapping here is what I inserted here. Mapping equals mapping. If this is confusing, we can Control C and paste this here. So this will still work. Now let me do Control Z. If what I just did is confusing. Now what I did is this. Why I didn't use demo, the assessor, that's the $sign retired, is because here I'm only doing like a rough work. This mapping here, or let me remove the G here and remove the G here so it won't be confusing. All right. So this mapping here is this mapping here. So which means that I've assigned all this AES here. Now why I'm doing this is because in ggplots and in R, and while doing this statistical program, you might need to do, it's like algebra, you might need to do a lot of substitutions and all of that. So this mapping is what is here. So when you see mapping, the one without the G, it means AES, X equals retired. Now, since data is already specified as demo, we don't need to use the assessor anymore. But in a case where we do not specify data to be demo, we can now use demo assessor mapping. Is it clear now?
Sorry, I got cut off. Well, maybe I understand later. My network was going up and down.
All right, sorry. All right, don't worry. When you get the video, you would understand. So we have like 5 more subtopics to go. Now, all right. So let's continue. Okay, one variable continuous. Let's see if there's anything in the PowerPoint to really talk about. Now, so we'll be looking at one variable as a continuous, one variable continuous when we need to plot one variable, and it's a continuous variable. In this section, we'll be looking at density and histogram plots. We'll also be looking at the box plots as well. Okay, we'll talk about it when we get there. Then one variable discrete as well. We'll look at the bar charts, just like we've done here. We'll look at the bar charts. Then 2 variables where we have continuous x-axis and continuous y-axis. When both of them are continuous, when dependence is continuous, the independent is continuous. We can use scatter, we can use line charts, and so on. Then 2 variables, we have discrete x and continuous y. The dependent variable is continuous, and the independent variable is discrete x and continuous y. Then the last one, I think, the last type of data we'll be looking at, charts we'll be looking at, is when we have discrete x and discrete y variable. That's this is called the bulb plots also. Then we have further readings. All right, so now we are back here. We have 1 hour. I'm going to treat 2 answer questions, then we'll treat the 3, then we'll see if we have more questions. All right, so for when we have one variable plot continuous, we can use a density plot. Now, density plots is cool, is okay. Continuous charts are, continuous data, just like we have in the demo here. Like age, income, car price, and all of that. So we can't use frequency for a continuous variable because it's not going to make so much meaning. Now, imagine you want to plot frequency for, like we plotted the counts for this. I want to plot counts for car price as well. Like, it's by chance that we are getting out of the 501 observations. It's by chance that we'll see two of them. I mean, one price appearing twice because there are different types of cars. Yeah, it could be a luxury car. Is it the type also matters, and different things could also determine the price. Is it used? Is it not used? So that's why this luxury car will be different from this luxury car, and so on. So that's why continuous data, either age or age. This age is still good because they are whole numbers. If you collect the exact age, like some people put if you put their age 5 years, 12, 11 months, 34 years, 6 months. Some people will even add the. So in that case, you might not have exact like one age repeating several times. So why we are able to do this for the bar chart is because there are several nodes repeating themselves several times. So for the continuous charts, the best way to represent them, to present them, is through continuous charts, like continuous data for continuous charts for continuous data, like density plots. Now, starting with density plot because I feel it's quite basic to express it shows the distribution and it shows a little information, well, a lot of information but compressed together. So to do your density plots, we have ggplot, then the demo. Remember, the demo is our data. Then we have the aesthetics, income. So once plots a density plot for income, then geo is density. All right. So I'm going to run this and let's see what we have. Now, here I wrote the comments here, local and global mappings. Remember, the aesthetic mapping is what is called mapping. It can be done in two ways, locally or globally. Let me check my charts. You know, it's taking long to come up. All right, okay. So let me explain the global and local mappings before going back to the charts. Now, here, remember what we did earlier was to close a bracket here and have close. Yeah, so this is what we had earlier, and this is called a local mapping. What we have originally is what's called global mapping. What's the difference? Now, the global mapping is putting everything. I think most of the things we did last week was global mapping, putting all the ggplot parts into the ggplots function, the ggplot function. So here we are putting the data and the aesthetics into the ggplots. That's the ggplot encompasses everything. So this is why this is called global mapping. While the other one that I did, I think I separated it somewhere. Okay, I didn't. All right. So now if I do it the other way, the local mapping, sorry, I'm trying to do so the local mapping, if you specify it 2 times, like I'm trying to struggle to explain what I'm saying. So if I have AES, yeah, AES, what other, okay, car price, CARPR plus, okay. So here I have specified a global mapping and I've specified a local mapping again, both of them in the same charts. Now I'm saying that plots income, then I'm saying plots car price. I hope this is car PR. Let me check so I can be, yeah, car PR. Okay. So let's see what will happen. What will R plots? So by default, R will use the local mapping to override the global mapping. Like the local mapping will always override the global mapping. I don't know why my chart is not showing until I zoom it. All right. Okay, it's showing. All right. So you can see we have what it did was to plot car PR and not the income. So what I'm trying to say is that the local mapping will always override the global mapping. So you have to note that sometimes it can be frustrating when you don't know. That's why I had to bring it up. All right, so let me rerun this. All right, so for the density plots, like I said, majorly density plots is used when you have very big data. It's much appreciated, like when you have very big data. Now it's a probability plot, and it can only tell us that from income of 300 below, like it tells us the distribution of 300 below, or the distribution of the whole chart, the whole variable itself. Now this chart is skewed, and this is skewed to the right. All right. So this is what descriptive plot can show us. Again, I can save this by, because I'm not specifying the name. This chart is not assigned to any name. So saving it, I'll just GG save and dense JPG height, blah blah blah. So it's going to know that the last plot that was plotted should be saved. All right. Now to add color and add some other things to your density plots, we have I jumped? Okay, so we have AS income, still the same thing that we are plotting, and giving it a color and line type. So in the line type, they are like 30 something. If I'm correct, it's in the PowerPoint. We have if you oh, okay. Oh, okay, here it's not here. It's not here. I think I specified it somewhere down there. We have a few of them. Like you can try different numbers with them. Alpha, like we learned last week, is the line thickness. Then size also size. Yeah, size of the line also. Then the fill, like size of the line type. Let me run this and see see what we have. Okay, now the dots that we have here is a function of the line type. If I change this line type to another number, we'll have a different type of dots. And if I change the size to something else, we have different size of the line type. All right. So you can, in essence, everything here can be manipulated. You can change it till you get what you are satisfied with. Let me change this 3 to 13, and let's see the line type that comes up. So I wanted to put there's a chart for the line types. I thought I put this in the PowerPoint, so it's fine. So okay, so this is another line type. It's thick, it's a line, it has bigger width. Then the colors too can also be changed. Yeah. Then on coloring as well, I dropped some links on the PowerPoints for different types of coloring. There are color palettes, and there's all sorts of different colors that you can use in our ggplots. All right. You can represent subset of a variable by assessing. Okay, so for this, okay, last week we did something similar to this. So you can represent subset of a variable by assigning the categorical variable to the argument group, fill or color. All right. So for fill, if I say fill equals gender, it's going to break the density plot into two: plot for male and plot for female, and give them different colors. Okay. It's not done running. While it's running, the red. Okay. Okay. So you can see the pink for female and green for male. We have two density plots: the green for male and pink for female. All right. Now that's a way of representing one continuous plot and one continuous data, yeah, in a plot. One continuous data, yeah, in a plot. The other way is histogram. Histogram give us more meanings than the density plots. Now, why did I say that? Because in histogram you can specify intervals in histogram. Though in density plots you can also infer intervals, but it's more appropriate in histograms. All right. So for plotting by histogram, I have f equals. Sorry. Okay, I used equals. So I can persist this. All right. ggplot demo, which is the data. AES, of course, the equal to will work. Like I said in that first class, I said equal to works, but this is more the assignment function is much appropriate. All right. So ggplot demo, AES, x equals income. So we assign all of this. This is our generic function. Sorry, this is our generic function, and we're assigning it to f. So whatever we need to build here, we only build it will build it on F, just plus geom histogram and geom box plots and any other thing we need to do. All right. So now to plot histogram, we are adding the geom histogram and specifying a bin width of 50. By default, R uses bin width of 30. Now the bin width, okay, then fill equals color. Let me just bring this down. Sorry, fill equals white, filling it with white, and color equals black. Now, what's the difference between fill and color? Fill fills inside the bar, while color fills the borders of the bar. All right. Okay, so let's see what we have here. So the bin width, it talks about the intervals. Now, if we have a minimum for the histogram, so it's going to plot the first one. Let me just show it. So saying, all right. So from here we have 0 to 50, 50 to 100, and so on. So in between here, income, the bar here is for those who earn 0 to 50. And the bar here is for those who earn 50 to 100, and so on. So the bin width is 50. Now, if we change the bin width and make it 25, we'll most likely have more, or not even most likely, we'll have more bars than what we had initially. All right, so you can see it now. So it depends on what's the intervals you're interested in. You can use it to plot your histogram. So that's why I say the histogram gives us much more, simplifies the charts. Okay, let me put it this way: it simplifies the charts than density plots. Like it's more easier for anybody to pick this up and say, okay, this one has like how many of them, because this is counts, the y-axis is counts, how many of them here. So it makes the continuous variable in intervals and plots them. All right. Now that's for bin width. There's another. Okay. Then apart from controlling for bin width, we can also control the number of bins that we have that we want to plot. So the number of bins here is, I can't count it because there are a lot of them that are very little around here. So here we specify bins equals 15. By default, it's going to create the bin width itself by giving us 15 bins. Okay, so we have 1, 2, 3, 4, 5, 6, 7. Then the rest of them are really little. Then here we have two models being, two mode bins together. But we might not be able. The problem with this is that we might not be able to say that this is from one particular point to another. We might not be able to say that, but specifying bin widths would tell us which intervals we are working with. Of course, except we simplify the x-axis to have more lines. All right, so we can also add more. Is there a few yellow? Okay, so this is more of the same thing here. Right. Okay, so here I was talking about the line type that we have from 0 equals blank, 1 is solid, 2 is dashed, and so on. So there are 6 types of line type, which is specified here that you can try out. Now, another way of representing a continuous chart is using frequency polygon. Let's look at that. Yeah, so the frequency polygon is just like the density plots. It needs to like density plot as well. Basically, it uses lines. The difference here is because I used line type equals 1. That's the difference. All right. Then we can also have the histogram and frequency polygon on the same chart. That's, we can have histogram and density plots on the same chart. So what I did was do the charts, the codes for the commands for histogram and save it with histo. The commands for the polygon charts and save it with poly. So what I did was then the F, which is generic code, and histo and poly, bringing them together. You can't run, if you run this, it's going to give us error, but you have to run all of these lines to have both of them. So when we run both of these lines, the histo is present in the R environment, and then the polygon is also present in the R environment. Bringing it together with the generic code, that function that we've written before, as the ggplot, the data demo, and the aesthetics. We can, for income, we have a histogram with a frequency polygon with it. So manually, what we do the frequency polygon, what we just do is to bring the intervals between, so the intervals between the charts. You can see for here the median, the median between or mean between the intervals is what is plotted as the frequency polygon, and it shows. So all of this that we are doing is just more of showing the distribution of the continuous variable. Another way to represent continuous variable is to use the box plots. To use the box plots, we have the geom box plots, and we have the data equals demo, which is our data. Then the aesthetics, nothing, because we have just for the box plots we have the y variable, and here we are using the car price and geom box plots. We run these. Now remember last week we learned about the box plots, and the box plots gives us like 5 estimates. 5 estimates. The minimum, the 25% quarter, the median, the 50% quarter, and the maximum. No, sorry, the 75% quarter and the maximum. So to know the values that is given in the box plots, we have the box plots is actually a very good plot. We have the minimum, the first quarter. If you run the summary and the data for each one, we have the values as represented in the box plot. Sorry. Now, the dots here is the minimum, and we have no dots is 4. I mean, the minimum is 4.4, and the first quarter is 13.82. That is this line here, while the median is 22.20, and mean. Okay, no, the third quarter, the mean is not represented here for the median. The third quarter is 42.42, and the maximum is 98.90. Now, the 98.90 is the highest one here. Those are the outliers. Now, last week we also learned that outliers can either be up or down. The box plot is good because it shows us where the outliers are. So here we can see that these outliers are around, this should be like 85 or like 87.5, thereabouts. Yeah, like 87.5 and above are outliers in these charts. Now, these are simple ways of representing your one variable continuous charts. It's not exhaustive, but because of little time that we have, these are common ones. Last week we saw the violin charts, which is also a way of representing the continuous variable. Now, the other one is, after this, I'm going to give space for questions because of time. The other one is one variable plots, which is discrete. And here we'll be talking about the bar charts. Again, in this bar chart, we are using one X variable, which is, so it's going to give us a count. Now, ggplot demo, which is our data, AES marital, like I said, you don't have to specify X equals this, Y equals this. The first argument you pass into it, into AES, into the mapping, is X, while the second one is Y. All right. Geom bar, then width of the bar, fill of the bar. Now, this fill can also be a categorical variable, but we'll get there when we get to categorical, representing 2 categorical variables. Then digititle, the theme. So we already know all of this. But what we are driving at here is that representing just one categorical variable, which is marital. There are other categorical variables in the demo data, but let's just go and work with this. So just like what we did earlier, we have a bar chart for marital status, one for the married and the other for the unmarried. They are almost the same here. All right, we can try to do a table to check what the actual values are. And in more advanced data visualization, we can also have, like some charts we have, we can also put the labels there, the exact values anywhere inside these charts. But our focus here is representing types of data with a chart, representing types of continuous charts when it is 1, discrete charts when it is 1. All right, so before we go into bivariate charts, as having 2 types of data, the X and Y, what we've done earlier is just univariate, either one continuous and then one discrete. So one discrete is usually represented with bar charts. Bar charts is just the best way to represent a discrete variable. While for well, according to my own opinion, others might have a different one. For continuous box plot and histogram is a good way of representing a single continuous data. All right, so for 5 minutes, let's see if there are any question. Okay. Okay. Ralph Oyedapo, yeah, you can. Yeah, raise your hand, you
Yeah,
can ask a
yeah,
question.
yeah. Okay, my question is in terms of in the argument, when we are trying to
Okay.
specify the color of the field and that of the line, can we place it anyhow or it has an order? Must the color come before, I mean, must the field come before the line color?
Okay. Sorry.
I think that's what I'm trying to say. In terms, okay, in the bar chart, and I try to give a color for the field
All right, please
as
hold on,
order
please.
of person.
Let me hold on, please. I just want to ask permission to go off video. So, all right. So you can continue.
Okay. In terms of the arguments, when we are trying to
All right.
specify the color for the field and that of the
Okay.
line, must the line come before the field or field before the line? We can just place those arguments the way we like. Is the command now to give us the final product, or it has a particular sequence they have to follow?
Really, they really don't. As long as you put fill equal to and color equal to. Once you put that, you are fine. Then what another thing that matters is where you put the color. Let me see. Okay, so here, say fill. Okay, yeah, fill here equals still blue. Now, if you put color in AES, sorry, if you put color in AES, what it's going to do is create another bar. It's just like make it, like I said, we are going to get there in group bar charts. But if it is here, you can leave it like you can leave it as fill equals still blue or color equals a particular thing. But for me, I think if you are using fill, use fill. If you are using color, and you just use color. Do you understand what I'm saying? I'm sorry, Ralph. Do you
Okay,
understand?
it's there. I get it clear now. It's better.
Okay. All right. Okay. 1 minute for another question. All right. So if there's none, we would continue. All right. So for two variables, continuous x and continuous y, or we have two continuous variables, x and y are both continuous, then we can use scatter plots. We did some scatter plots also last week. So this will just be a run through. Now, like I said, anything that is going to be generic or using over and over again, the base of our ggplots, you can assign it to an object. So it can be a letter, it can be a word, it can be anything. But I think in the first class I talked about the rules. You don't start with numbers, you don't have spaces in between, and so on. Okay, so here we have ggplot demo. Demo is our data, and here AES, that's the mapping age and income. Fine. So, Sarah, I hope this is some of your questions. I mean, I hope the remaining part of the class will answer your question. Now, we have two continuous variables. Age is continuous, and income is continuous. Then we are specifying color now to be retired. Remember, retired takes either yes or no. You're either retired or not, or you're still active in service. All right. So if we run this, I want to plot a scatter plot. The function for scatter plot is geopoint. Now, if we call h now, h is going to be nothing because we've not told it what to plot. We've not given it any geometry function. All right. So adding the h to adding geopoint to h. All right, adding geopoint to h will create geopoint, but nothing again here because sorry, I need to call h to show the data. Oh, okay, yeah, I've done that before. Just adding. It already brought it. Okay. H is the data plus the aesthetics, while adding geom points gives us the scatter plots. It informs ggplot what to plot. We want to plot a scatter plot. All right, let's see, since this part is not bringing out, it's not bringing out the chart. All right, now remember we said color. The color should be color it by retired. So we have a lot of them who are not retired, and those who are not retired happen to, they are the ones in the outlier and the ones earning more than those who are retired. Only a few of the retired earn around 150, maybe 1,000 naira per month. All right. While those who are active still earn a lot of money. All right. So this distinguishes the plots. The color here, passing color into aesthetics would distinguish the types. I mean the plots. If it is bar, it's going to distinguish it so in a way we are going to see. And if it is scatter, it's going to distinguish it this way as well and puts a legend here. All right. Okay. So then we can show the relationship with the fitted regression line. Okay, so all of this were some of the things we did last week. And how do we do that? We just genome smooth method equals LM. So the LM is also a function in ggplot. ggplot understands that it's linear model, and formula is y to the x, that's x on y. Then color is blue, that's color of the line type to size to fill red and all of that. Now we have color in our aesthetics already. That's that H. Yeah, that's H. Well, fill here is red. So let's see what we have. Okay, so this is smooth. Smooth is only going to give us a line without the dots. Let's see. Okay, I'm still running. When this red button leaves, that means it has finished running. So we'll have to wait till it does. Now, this is going to be okay, so this is going to bring only one line. Yeah. So this is the line, and we also learned that the interval here is the standard error intervals, as like the confidence intervals of this estimate, of the line. All right. Now, if we wanted to show the dots, like the scatter plots alongside it, we can add the geom point to it. The plus geom point will give us the scatter plot, and I think it's below here. Okay. Okay. Yeah, it's still down there, so I don't have to do it here. Now, this is representing the two continuous data using a fitted line and showing the standard errors at each point of the line. All right. Then here we can use a line graph to also represent the two continuous variable of age and income. Have two lines here representing one for male and one for female, because we added color for gender. This time around, we are not using the age. So because we added color for gender, we have the two groups for female and male. Without specifying this, we are going to have that just one line, fitting the regression line, just one in the chart, in the line graph. All right. Now, we can also remove the standard error intervals. We can remove them by specifying SE equals false in the geometric function. We can remove the standard error lines if we want to. Intervals if we want to. So if we run this, we have the lines without the standard error. All right. So now without standard error. So in whichever way we want to present the data, the variables, the two continuous variables, we can always use them without the interval. With the interval, sometimes it gets like an instruction not to add. Sometimes you get instructions to add. You know what to do. Adding the standard error intervals and not adding the standard error intervals. All right. So we already learned about the titles and the X labels and the Y labels. All right. Then when we have discrete and continuous variables, x is discrete and y is continuous. You know, it's different when y is continuous and x is discrete. When x is discrete and y is continuous. No, I don't think y can't be discrete and x continuous. All right. So x discrete and y continuous in this chart. Now we can use a bar plot. Now this bar plot is quite different from the bar plot we've used before. This one is plotting retired against income. Now retired is yes or no. It is discrete. It's categorical. Y income is continuous. So we have data equals demo, and our AES is x and y. Remember, I said you can also do it without passing stating the x and y. Once you state the first argument ggplot R recognizes it as x, while the other one is recognized as y. All right, so we assign this to P. Then we can plot the bar charts by stating all of this. Of course, remember I said by putting only bar would also do the work. Now, all of these arguments inside here are just trying to streamline or customize what our bar charts will look like. Now, running this, let's see what will be produced. Remember the first bar chart we produced where we had retired, no or yes. What we had here was count, but now we are telling it to plot it against income. Now, this chart is really saying something very minimal, just saying that all those who are retired, like the highest person who is not retired, earns like 40, I think like 40,000 naira. So the highest person who is not retired earns this amount, close to 40,000, because he's not meeting the line, close to 40,000 naira. While those who are retired earn very less, like the highest person here earns very less. Now, inside this bar are also some people who are retired, sorry, who are not retired, who earn like 10,000 naira, 20,000 naira in between all of this. So that's why I said what the chart is presenting is quite limited. It's quite limited, but at least it's something. We know in general that those who are not, according to this data, those who are not retired earn more than those who are retired. All right, that's a general way of presenting a discrete and continuous. But for the box plots can also come in, which is a very good plot to use here, because the box plot is going to show the outliers, it's to show the median, and it's going to show some quartiles also, and comparing them. So let's see what we have for the box plots for retired and income. All right, let me zoom it. Yeah. Now we might not appreciate this box plot so much here, but for when the data looks alike, because the difference between these two is obviously very large, but when it's more of a data that is relating, would appreciate it more, because this information is giving us is going to throw more light. Actually, even here now, it still throws more light than having that box plots. So we can see that those who earned really high among those who are not retired are just a few. But the box plot is showing us as if almost all of them, all those who are earning, all those who are active in work, like all of them are earning. That's what the box plot is presenting like. That's what it looks like for those who do not know. While here, all of these guys are outliers. All of them, they are outside the 75%. So they are outliers, all of them. All those who are earning a lot here are outliers. While for those who are retired also, we have 3 of them who are outliers. So looking at it, it's still quite two different, a lot of space in between, but not as much as what the box plot has presented. This drives home more points than the box, I keep saying box plots, like the bar plots. The box plot is a better representation or presentation of data. So yeah, anytime you have a continuous data, you can always bank on the box plot to do justice to it. Then the last type of combinations we'll be looking at tonight is we have discrete X and discrete Y. Now, there are different types of combinations also. It's possible to have 3 different types of data combination. One will have field, which we'll soon see. But here we are limiting this class to discrete X and discrete Y. All right. Now, here we're looking at the bubble plots. Now, the bubble plot is an interesting plot because it shows. Let me plot it. It's because like you would not know that there's a way you can plot a categorical data together, but the box plot does that. I mean, the bubble plot does that. So the our session about it. I think this happened last week. So let me quickly start a new one. Okay. All right. So maybe you can use this to ask question. I think this I'll have to look into this. Maybe there is. I don't know. I don't think there should be a few number of hours that you can use. I mean that you can use R with when it's not Zoom. It also happened last week while Prof was teaching. So I'm restarting. So if you have a question, you can ask now before I come back, before it restarts.
Okay, so well, I think mine is more of a comment. So
Okay.
yeah, I think the one Prof taught last week. I think was it the plot function or
Q,
the one that's the one
Q,
that automatically q
yeah,
plot. Yeah,
the Q
yeah, the
plot,
one
yes.
that's yeah, it doesn't stress you as far trying to define
Yeah,
the
so
dual function and all.
if you check the if you check the video again, Prof said that there's a Q plots and then we have the GG plots. That the GG plots is more flexible than the Q plots. So there's a limit to what the Q plots can do. That's why we started with the Q plots. Do you understand?
Yes, I do.
So there's a limit to what. So the Q plots would plot it automatically. It's less stressful. But if you want more more customization and all of that to your plots, you might have to use the plots. Or if you want a quick, just like the name Q plot is a quick plot. So it's meant to introduce us to so that we get familiar with what the GG plots does.
Okay, then one more thing. That it seems like it's expendable. It can be most of it is also
Yes,
repeated in the okay.
in the geom parts, the geometric parts.
Well, both geometric pattern and even in the ggplot function too.
Okay, did you miss when I was explaining the local and the global option?
No, I was there. I remember when you mentioned
Yeah.
it.
So I when sometimes we use AES in the ggplot function, like inside the brackets for the ggplot function, then sometimes it is brought out, like we bring it out. So and I said that anytime we use it inside and outside, ggplot would pick the one for the outside. It would pick the one outside of it. That's the local one. That's what ggplot would use. You get.
Okay.
So
Yes.
anytime you see AES outside, I mean inside ggplots, and AES is used to specify your X and Y. Of course, you can also specify fill and color in it as well. If you see fill and color somewhere else again that has AES, R is going to neglect the one that is inside ggplots and use the one outside. But if the fill and color and any other argument you see inside AES is used on the geometry, it is only specifying what should be applied to the bars or the dots if it's a scatter plot. So there are different. The AES functions takes different arguments. The geom functions can also take some of those arguments, but they also take a lot of arguments as well. I think Prof mentioned it last week too, that the AES function has different arguments that can be passed. The geom function also has different arguments that can be passed in them. All right, let me go and bring in my data because this session just started. Set working directory, syllabus. Yeah, I know it's here, but I don't want to stress myself. Let me just bring it in. I think that, okay, I might need to run all of this as well. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . All right. So I guess we can then go to the last part, the bubble plot. Okay. So now this is on one x-axis discrete and the y-axis discrete, the bubble plot. So what it's going to do is plot gender on x-axis, plot marital status on y-axis. Then now what's going to do, marital is you're either married or unmarried, while gender is you're either female or married. Now these bubbles are representing the number of females who are married, then this small bubble is representing number of female who are unmarried, number of male who are married is little, while number of male who are unmarried is a lot here. Okay, so at least one thing this data is telling us is that the data is not collected from couples, because if they are collected from couples, we shouldn't have more female married than male. Okay, except the males are polygamous. All right. Now, okay, so let's go back to the chart. Now, the legend is trying to show us the size of the circles. Now, for this circle, I can only assume that this is like only one female that is unmarried, and while here this is almost like this is about 130 male that are unmarried. This is about this. So this, although this is a great way, is a good way. I think it's a good way. But if you can find your way of maybe creating a contingency table, it would explain these data points well. One, two, if you can bring in your labels on top of each of them, each of the bubbles, it will be more give more information, more accurate information than this. So this is only giving like approximate information. But majorly, what it's saying is that the biggest bubble is 135. Yeah, but this is not 135. So this bubble, judging with the eye, is around 130, while this is around 125. That we can all as well guess for all of this as well. So the bubble chart is good for discrete and discrete variables, while multiple bar charts. Okay, so multiple bar charts we have is also discrete and discrete. We have AS car category. I think car category is like 3, luxury and some other one. Then field marital. We want to see what people who are married and people who are married uses. So if we save this into K, Control Enter, and then geobar. Now for a multiple bar chart, we use geobar as well. The only thing that differentiates it is the position, which is dodge. Now, if you plot dodge, it's going to put it side by side. There's another option for stack. If I'm correct, stack. Is it? I don't know if this is spelling, but okay, let me zoom. Stack. What stack will do is going to put it on top of each other. That's a composition chart. So we have married the pink, unmarried green. Well, so the married people use less economy, yeah, than the unmarried. While luxury cars, married people use more luxury cars than the unmarried. While married people as well use more standard cars than the unmarried. Okay, that's for multiple bar charts. While for component bar charts, we use fill. The fill arguments would make a component bar chart. Personally, component bar chart is good for maybe comparing, but I think the multiple bar chart is a better way of comparing than the component bar chart. But it all depends on what you are trying to do and how you are trying to present your data. Okay, let's see. All right. So for the components bar charts, we have, so it just puts everything into, like, everything adds up to 1. So you have like percentage. So over 50% of unmarried people use economy, while less than 50% of unmarried people use luxury, and again less than half of all the people who use standard cars are unmarried. Okay, I think that's a better way of saying it. Among all the people who use economy, over 50% of them are unmarried, while among all those who use luxury cars, close to 50% of them are unmarried, while among those who use standard we have about maybe 40% of them, or about 40% of them, to be unmarried. Yeah. So that's the difference between the component bar charts and the multiple bar charts. So these are few ways of representing this data and possible combination of data you will be mixing and how to represent them in R. And of course, remember you can also add some other things like the labs and the themes and all of that to specify your charts by using plus to add new labels. All right, so let's take question for the next 3 minutes. And someone is raising up their hand. Mr. Yaridi. Okay.
Yeah, thank you. Please,
Thank
thanks so much for the beautiful presentation. It's been very, very impressive. Thank you and educative.
Yes, sir.
Now, I want to ask one or two things about this local and global, local
Okay.
mapping and global mapping. You did a
Okay.
lot of explanation. Unfortunately, my network was cut off, so I couldn't hear you well. From this, the little thing I heard about global, you said AES is used for specifying X and Y.
Yes.
And also, it can as well be used to specify fill and
Yes.
color.
Yes.
And so, what in first instance, what is the difference between fields and color? Can they use interchangeably? When you use
Yeah.
fill, does it perform the same function as color?
Okay. So you can use fill and color. Most times, color inside AEX would color the outer part of the charts. That's what I'm saying. The boundary. The color
Okay.
inside
Now,
AEX. Yeah.
yeah, I think I get that now. Now, now you now say that when either fields and color are used outside the bracket, you said it is
Yeah.
called local. Please, can you give us an explanation or a script line that indicates local and another one in the same form, in the same on just below it that indicates global?
Okay. I think probably that was when your network left. I
Okay.
demonstrated it the other time, but let me show you again. Let me do. So what I was saying then was that about local and global is that when you have AES for, okay, so let me just use here. And if I have AES, what X variable can I is gender. Right. So now this is a global mapping. Because why is it global? It's because let me write it here. Now it's global because the AES is specified inside the general ggplot function. Now I now said that when AES is specified again locally, this is a local mapping. Locally is say what we had initially before. That was when this was not there. This is what we had initially. So this is a local form of mapping. Now, when we have both of them together, global and mapping, and the both AES are still specifying the same thing. Remember we said that the first thing AES would collect is your x-axis, the second is your y. Now, here, this is our x, and this is our x again. Now, instead of R to be confused that why am I having two variables on the x-axis, it will rather take the local one and leave the global mapping. So no matter what you've written here, fill, color, and all of that, R is going to neglect what is in the global and plot what is in the local. So let's see. Let me remove this first and plot what we have initially. So this is the global mapping. This is the local mapping. Like it's just ggplot, the data, AES, the marital, geombar, and all of that. Now let's see what we have. What we are plotting now is marital. You are either you are married or unmarried. Fine. Now let me put the global function and remove the local. Okay, I don't even have to remove it. Once I put the comments, it becomes the comments. So R is going to skip from plus here and come to geombar. So if I run this, it's going to plot gender. Yeah. So why am I still having marital status? Let Yes. Oh, sorry. Because my X lab is marital status. So it's not, you can see marital status cannot be female and male. So it's not marital status. This is gender. All right. So we have gender. Now, if I remove this, so we've seen that AES works when we put it in the global environment, and AES works when we put it in the local mapping. Sorry. Now, if we now put both of them, local and global, together, what I'm saying is that R or ggplot is going to neglect all of this and come and pick the local. So if I plot this now, it's going to be marital. You are either married or unmarried. That's what we'll have here. Yeah, so either married or unmarried. So whatever has been specified in the global option of AES would be left. So is either you are using the global or you are using the local. Or if you have to use both of them, maybe you specified X and Y in your global, and in the local mapping, you now put fill equal to this, color equal to this. That would still work because it is not conflicting with what you have there before. So, just in summary, if you have the same thing in local and global environments of AES, in global mapping AES, R is going to neglect whatever is in the global and pick what is in local.
So, sir, if I may infer something from what you have said now.
All right.
Are you hearing me?
I can hear
It is
you.
possible for us to use the concept of global and local to plot three different variables together on a graph.
No,
So
how can you do that? When I said it's going to
okay, this is where I'm going.
Okay.
It's possible for us to have on the x-axis a continuous variable.
Okay.
In our aesthetics, then we have in the y-axis a discrete variable. Then we use fill in the local mapping.
Okay.
We use another discrete variable in the local mapping as fill. So
As
we'll
okay.
yes. So
yes,
we'll
yeah, you can do that. But you can also do all of that inside global or inside local. It's fine. You can I think we even did something like that. You can do that.
So we can use those three variables.
Yes, so it's like having it would be like having grouped bar charts, and now having the field will now be something else. Like it will be a variable. So the colors inside will now be specifying another variable. Then to give you a legend.
Okay. Can you give us an example of that? Can you write a script that represents that for us?
Let's see. So here, where is the multiple bar charts? So here we have car. I'm sorry, car category, and field is marital. Okay, and okay, why can be income, right?
Yes.
Income, comma. So let's see what we have. Okay, so can only have X or Y as blah blah blah. Let me see. Geo bar, right? Multiple bar charts. Position equals search. That counts. Okay. Geo bar. And then let's change this. Next one. Okay. I don't think. It's possible to have that. It has to do with one of the arguments that is passed there that will make it accept that kind of XY variable. Let me go to when we had the bar charts. That's discrete and continuous. Discrete and continuous. This is continuous, and discrete and continuous. Yeah. Okay. Okay, stats equals identity. All right, so let me see now. Let me see. Fill equals marital, right? Sorry, it highlighted something, so I don't know what it's doing. Like it highlighted what I run was what was highlighted. So let me do this again. We have without income. Okay. Now I want to remove this field. And, I'm trying to. So here, this field here, I doubt if this is going to work because the geom, we're not supposed to specify anything. It's not going to work. Marital is not found. Okay. All right. So I'm going to try this and maybe send the code on announcements in the group so that we won't waste some people's time.
Okay.
All right.
Doctor, because you put the field in brackets, you didn't put equals to for that one.
Okay. Let's see. Okay. Yeah, I say the same thing. Because, okay, maybe I should remove this and let's see. I think let me go and sort it and put it on the because it will still need a position equals dodge. I think that so that's what. Yep. So here we have married and unmarried and retired then income. So are we good? Are we satisfied?
Please let us see the script that you used in plotting.
Okay, all right. So ggplot data equals demo. We have the x-axis, the y-axis, then the field is marital. So the rest is so I removed field in the geom bar, so it won't conflict with the field here.
Okay.
Yeah.
Okay.
So that's why we are able to like this. So one important thing is this stats equals identity. So this stats equals identity is the one that makes it plots for y-axis that is continuous variable. Without this, it's not going to work.
Without what?
Without the stats equals identity. I think, but yeah, it will work because by default it is stats equals identity. So it will work. So basically, the code that gave us this is AES retired, X equals retired, Y equals income, field is marital. So field is what's brought about the legend, the inside of it. If we have color equals something, that will be the color of the outside line. The outside line here now is transparent. So field gives us the colors that are inside the bars. And that's why we have these representations here. All right. So I guess that will be the last question. Okay, maybe I should copy this and paste it on the, for those who might want to, should I? I can copy this too and paste it on the announcements so that we won't waste time. People can leave and get to bed. All right. Is the admin still there? Thank you very much.